Okay, hello guys, welcome to this class. And in the last class, we talked about machine. And when we talk about machine, we said that a machine is a device which enables a force at a point to overcome a load at another point, right? Then working on other points, the overall thing is that it makes the work easier. So we defined some terms about machine, but we said mechanical advantage, MA, is how much the machine has been able to help your force, right? So is the ratio of load to effort, right? We said that velocity ratio is the ratio of distance moved by load. Are we getting it? Distance moved by load. Distance moved by load. Distance moved by load. All over distance moved by effort. No, sorry. Is distance moved by effort? Distance moved by effort. All over distance moved by load, right? So we say that velocity ratio is distance moved by effort over distance moved by load. And we now said that efficiency, EF, is the ratio of mechanical advantage to velocity ratio times what? 100. And also we said that mechanical advantage is work done by the load over work done by effort times 100, right? And we gave some kind of things. Okay, so we are going to be using those formulas in solving problems, right? We'll be using those formulas to solve problems. And after we solve those problems, the next class will be on types of machine, right? So we just solve simple question like 2 or 3. Then on that type of machine, that is where after explaining that, we now round it up with the final problem. All right, so we go to type of machine. No, sorry, we go to our first problem here. It says a simple machine has an effort. You know, in physics, when you are reading the question, you write it out, right? A simple machine has an effort of 2 newtons. So we say that E is equal to what? 2 newtons. Are we getting it? Over a distance of 5 meters. So we say that the distance here, distance equal to what? 5 meters. Are we getting it? It's used to push a load of 8 newtons. So L here is what? 8 newtons. Over a distance. Now the distance moved by this load is what? The distance of load is equal to what? 1 meter. Now this side is distance of what? Effort. Are we getting it? Okay. Now let's say A, find the velocity ratio of the machine. A, velocity ratio. We know that velocity ratio is equal to what? Distance moved by effort over distance moved by load, right? Now distance moved by effort from here, first of all write it down. Velocity ratio is distance moved by effort all over what? Distance by load. Distance moved by load, right? So V arrow will now be distance moved by effort from the question is what? 5 meters. So that will be 5 meters will be on top, right? Over distance moved by load. And distance moved by load here is what? 1 meter, right? So 5 over 1 is the same thing as what? 5. So the velocity ratio of the machine is what? Is 5. Now what is the unit of velocity ratio? The velocity ratio doesn't have unit because distance moved by effort and distance moved by load, distance and distance are the same unit. So when the, okay, let us say this is 5 meter, 5m, 1m, right? M cancel m, so there will not be unit here, right? Okay, very simple. Now the next question here is the mechanical advantage of the machine, FA. We know that FA, are we getting it? FA is equal to what? Effort. Oh, sorry, MA is equal to load over effort, right? That will be MA is equal to load over effort, right? Now the load here is what? 8 newton. And the effort here is what? 2 Newton. So 8 over 2 is the same thing as what? 4. So the mechanical advantage of the machine is 4. Also again, mechanical advantage have no unit. Why? Because this is 8 Newton and this is 2 Newton. What happened? Newton and Newton will cancel out, right? Newton and Newton cancel out. There will be no unit here, so it will be 4. Now the next question here is, what is the efficiency of the machine? And I tell you should remember efficiency. Remember the name Marvelous, MA over V arrow, right? Times what? 100. Now we have calculated the mechanical advantage to be 4. So that will be 4. And the velocity ratio to be what? To be 5, right? So MA is 4. Okay, we are following it. And V arrow is 5, right? Now times 100. So 5 going to here 1, 5 going to 100 is 20, right? So 20 times 4 is equal to what? 80. So the efficiency of the machine is 80%, right? So simple as that, very easy. Now let us go to our number 2 question. It says an effort of 300 Newton is applied to a machine to lift a load of 1,500. The machine has a velocity ratio of 20. Calculate A, the mechanical advantage, and number 2, the efficiency of the machine. First of all, what you should understand here is that you are giving effort. So when you are giving effort, you are giving E to be equal to 300, right? 300 Newton. It's applied to a machine to lift a load. So the load here, are we getting it? Is 1,500. Any complaint? No. Okay, the machine has a velocity ratio of 20. So V arrow here is what? 20, right? Now they are asking you to calculate the mechanical advantage. Now when they ask you to do something like this, what do? First of all, you recall that mechanical advantage, you get the formula of what they are asking you to calculate for. Now, what's mechanical advantage? Mechanical advantage, NA, is equal to what? Load over effort, right? Now, we have given load as 1,500 and we are giving effort as 300. So we just substitute to this equation. MA will be equal to 1,500 over, sorry, my pen is missing, over what? Over 300, right? So 0 cancel 0, 3 going to here 1, 3 going to here 5. So mechanical advantage here is 5, right? Now what of the efficiency? The efficiency will now be, we remember the name Marvelous, efficiency equal to Marvelous, so that will be MA over V arrow times 100, right? So we have calculated MA to be what? 5, so that efficiency will be equal to 5 over now the velocity ratio from the question is 20, right? Times 100. So 20 going to here 1, 20 going to here is 5, right? So 5 times 5 is 25. So the efficiency of the machine is 25%.